Question 7 is a standard projectiles question. So there's this person playing Camogie. They're 35 meters away from the goal line, and initial velocity is 20, angle is alpha. This goal is 2.5 meters above the ground, and we're asked to derive an expression in terms of alpha for the time taken to reach the goal line. So since the goal line is to do with the horizontal distance, we will deal with the x direction first. So we'll have S, U, A, and T. We're not going to bother with V because you usually don't really use it in projectiles. So it goes 35 meters, or sorry, 35 meters. Initial velocity will be 20 cos alpha. Acceleration is 0, and the time is t. So S equals ut. We're looking for the time taken, so we'll get 35 equals 20 cos alpha times t, which means that t will be 35 over 20, which is 7 over 4. 7, actually I'll write it as 7 over 4 cos alpha when you simplify it. And that's an expression for time, and it's in terms of alpha. So yeah, that's it. In part 2 then, we're asked to calculate the values of alpha such that the slitter hits the crossbar. So now we'll have to start talking about the y direction as well. So this x direction kind of covers this criteria because it's 35 meters away. Now let's look at the y direction. We have S, U, V, A, or S, U, A, and T, we'll say. So the displacement is 2.5 meters is how high the crossbar is. Initial velocity will be 20 sine alpha. Acceleration is always minus g, and the time taken is the same time, which we're just going to call t. So S equals ut plus a half at squared. So 2.5 equals ut, sorry, not ut, we know what u is. It'll be 20t sine alpha. I'm just putting the t there so it doesn't look like it's multiplied by the alpha inside of the sine. And then we'll have minus a half at squared is minus gt squared over 2. Now, we can't isolate for t here. We're trying to find alpha, so we need to get rid of the t. But we know we can that t is equal to this, so we can replace it with that. 2.5 will be equal to 20 sine alpha. And then replace the t. It's 7 over 4 cos alpha. Minus g over 2 times t squared. Square each thing, we'll have 49 over 16 cos squared alpha. And we'll have to use a trig identity here. So we can get alpha, you'll see now in a second. 2.5, so 20 divided by 4 is 5. 5 times 7 is 35. Then sine alpha over cos alpha is tan alpha. Then we'll have minus 49g over 32. And instead of writing cos squared, I'm going to write this as secant squared, sec squared alpha, because we can use an identity. So since we need to solve for alpha, we can't do that when there's two different trigonometric functions. We have tan and we have secant squared. But we can use this trigonometric identity, which you often have to use in projectiles, that sec squared of a is 1 plus tan squared a. So we can sub that in here. So, sorry, this is a g. I'm just going to make it look like it. So everything else stays the same. We're going to replace that sec squared with 1 plus tan squared alpha. Okay? Now, when we expand out that bracket, we'll get minus 49g minus 49g over 32 tan squared alpha. Now we'll just bring everything over to the left side. So we'll get 49g over 32 tan squared alpha minus 35 tan alpha. And then we'll have 2.5 plus 49g over 32. So when you bring this to the other side and you add it to that, what you get is plus, it's 2801 over 160. That's equal to 0. Now we can use the quadratic formula to find tan alpha. So tan alpha equals, it's always good to write the formula just in case, b squared minus 4ac all over 2a. It's equal to negative b, so we'll have 35 plus or minus the square root of b squared. That's going to be 35 squared minus 4 times, okay, so we have 49g over 32 times 2801 over 160 all over, that'll be, oh god, 2 times 49g over 32. Okay, that's quite messy, but we'll simplify it now. So you get 35 plus or minus, the square root of that big thing is plus or minus about 13.2 roughly, all over all over about 30.0125. So that's what tan alpha is. So that means that alpha, or yeah, I'll write the full. So tan alpha is that. That means that alpha is given by the tan inverse of that. So 35 plus or minus 13.2 over 30.0125. We're asked to find the angles, so the values of alpha. So we're expecting two answers because we have the plus and minus anyway. So let's go for the plus option. We have alpha is going to be the tan inverse of 35 plus 13.2 over 30.0125, which is equal to whatever. And then we'll do minus alpha equals tan inverse 35 minus 13.2 over 30.0125. Put those into your calculator. For the first one, we get 58.09 degrees. And then for the second one, we get 35.99 degrees. So there are two answers there for alpha. This could possibly be the worst question on the exam, because on top of that really messy projectiles question, we have a really messy horizontal circular motion question as well. So we have some information. Diameter is 20 meters. That means that the radius will be 10. Motorcyclist on a motorbike labeled M. He has a mass of M, and he moves in horizontal circular motion. We know what the angle beta is. We're ignoring friction for now. Draw the forces acting on M. Well, so we'll have obviously mg, the weight going down. We'll resolve that so we're pointing towards the center of the circle as well. So let's have a look at our angle. You can see that these are corresponding angles. If this is beta, then this is also beta. So we don't need to worry about that too much. Then as well as that, because it's touching the sphere, we're also going to have a reaction force pointing that way. So this will be W cos beta, and this will be W sine beta. And that's all the forces, because we're ignoring friction. We're then told to calculate the velocity. So before we do that, it would help to figure out what sine and cos of beta are. So if we know that tan inverse of beta, or beta is the tan inverse of 4 over 3, that means that tan beta equals 4 over 3. So what do we have? We have a right angle triangle. Opposite, tan is opposite over adjacent. This is a 3, 4, 5 triangle. If you find the hypotenuse, that means that we have sine of beta equals opposite over hypotenuse is 4/5, and cos of beta will be 3/5. So now we know that, so it'll be nice when we're calculating the velocity. So in horizontal circular motion, always two facts: force up equals force down. That means that we have we shouldn't actually resolve the weight, won't help us very much, because the center of the circle is here. He's moving in a horizontal circle. So in reality, we don't need to resolve the weight. We actually need to resolve the reaction force. So we'll have or cos beta, it'll be or sine beta. Okay. So we'll have force up equals force down, or cos beta will be equal to the weight, which is just mg. Cos beta is 3/5, so we have 3 over 5 or equals mg. Other fact is the centripetal force is mv squared over the radius, which is equal to, it's just the or sine beta, going towards the center. We want to get v, so we can replace or. Let's find out what or is. Or is equal to 5 mg over 3. So m we don't know. V squared is what we're looking for. The radius is 10, because the diameter of the sphere is 20, so the radius is 10. That'll be equal to or, which is 5 mg over 3, times sine beta, which is 4/5. So we get that. The m's will cancel. We get v squared over 10 equals, those 5's cancel. We get 4 mg over 3. Multiply by 10, take the square root. V will be equal to the square root of 40 mg over 3. Put that into your calculator. Or sorry, not 40 mg. We cancelled out the m's. It's just 40g over 3, and then you can put that into your calculator. We get our velocity to be 11.43 meters per second. And that's the answer for the first part. Well, that was actually the second part. Okay. Now we're involving friction as well. So we're doing another force diagram, quite handy. So same deal. We have weight going down. We have the reaction force going towards the center. And we can resolve that. Again, might not have to. It's or cos beta. This is or sine beta. And then if it's about to slip downwards, that means, remember, friction opposes motion. So if it's about to go this way, that means friction is going to be going up this way. So it's going to be perpendicular to the reaction force, kind of going up towards the thing. This is going to be friction, the force of friction. We'll resolve that now in a second, just because I want to show the... Yeah, I'll do it now. So in terms of the angles, it's a little more complicated, at least unless you can eyeball it or there's another method, but I always do it out like this. Okay, so if this is right angled and this is beta, this is 90 minus beta. We know that the friction and the reaction force are perpendicular, so that's 90. And this is the angle we're looking for, this question mark. The question mark plus 90 minus beta equals 180, because it's a straight line here. That means that our question mark angle is actually just equal to beta. So in terms of resolving this force, our beta is actually here this time. So this will be the force of friction sine beta. And down here will be the force of friction cos beta. And there we go. That's all the forces, and they're resolved. So then we're told that m has a velocity of this when it's on the point of slipping downwards. Calculate the value of mu. So remember, the coefficient of friction is mu, so that's what we're looking for. So as always, force up equals force down. So we have that, okay, lots of forces going on now. We have the force of friction times sine of beta plus the reaction force times the cos of beta will be equal to the weight, which is mg. So let's figure out the force of friction is always equal to mu times the reaction force. So we'll have mu or, and then sine beta, we figured out. Sine beta is 4/5. So we'll go 4 over 5 plus, and then cos beta is 3/5, or that's equal to mg. We won't do anything with that yet because we don't know what we need. Next thing is the centripetal force will be equal to mv squared over or, as always. That's equal to, you can see we have or sine beta minus the friction, which is mu or cos beta. Okay, because they're going in opposite directions. So it's obvious here we need to get rid of or because we're looking for mu. So let's try to get rid of or in this equation because we know everything else. So here if we try to get or, we'll see that or multiplied by... I'm trying to think if there's a better way to do this. I think if we multiply by 5, it'll work out a bit nicer. So let's multiply by 5, we get 4 mu or plus 3 or equals 5 mg. Try to get r by itself. R times 4 mu plus 3 is 5 mg. That means that or is just equal to 5 mg over 4 mu plus 3. Let's sub it in here. So mass we don't know. Velocity is 7.5 squared. Radius is 10. That's still times the mass equals... I'll factor out an or here just so I don't have to write this big thing down twice. So or, which is 5 mg over 4 mu plus 3 multiplied by sine beta. Sine beta is 4/5 minus, and then mu times cos beta, which is 3/5. So I'll say 3 over 5 mu. Okay, now we just have to solve, those m's will cancel, now we just have to solve for mu. So 7.5 squared over 2 equals, okay, 5 there, they'll all cancel. That's quite nice. We'll have 4 minus 3 mu over, or times g as well. Because that g is up there, and then the 5's will cancel. Yep. Then we have 4 mu plus 3. Okay, cool. So now we can bring the g down and bring those up. So, and I'll start to get a number on this now. So I'm gonna bring the g down here. I'm gonna get a number on the left hand side now because I'm gonna need to simplify a bit. So 7.5 squared over 10 times 9.8. That'll give us, okay, it's kind of a weird number. It's 225 over 392. Now, obviously, you could probably get a decimal on this. I just like to be really accurate. That's going to be equal to 4 minus 3 mu over 4 mu plus 3. We can just cross multiply now. So we'll have that. So it'll be 4 mu plus 3. 225 times 4 mu plus 3 equals 392 times 4 minus 3 mu. Expand out those brackets. 225 times 4. It's 900 mu plus, and then multiply it by 3. That's 675 equals 392 times 4 is 1568 minus, and then times 3, 1176 mu. This is why this is the worst question on the exam. Okay, bring the mu's to the left side. We'll have 900 plus 1176 is 2076 mu equals, and then 1568 minus 675 is 893. So mu is just going to be 893 over 2076, which, if you put into your calculator, is about 0.43. So that's what mu is.